Hello and welcome to Magnetic Learning. In this session, we are going to learn about equivalent fractions. So let's get started. Let's take an example first. Rohan called his two friends for a pizza party at his home. His mother made 3 pizzas for each one of them. Rohan divided his pizza into 2 halves and ate 1 half. So Rohan, what did he do? Yes, Rohan divided his pizza into 2 halves and he ate only 1 part. Therefore, he had only half of the pizza. So what do we understand with this? That whole pizza was cut into 2 parts by Rohan and then he ate half of the pizza. He had half of the pizza. Now, first friend divided his pizza into 4 equal parts. How many parts? 4 equal parts. 1, 2, 3 and 4. And he ate only 2 parts. How many parts? 2 parts. So there were 4 parts and his friend had only 2 parts. So what is the fractional representation for his pizza, his share of pizza? He had 2/4 or we can say 2/4 of the pizza. Now let's come to his second friend. His second friend divided his pizza into 8 equal parts and he ate 4 parts. How many parts? 4 parts. 1, 2, 3, 4. So what is the fractional representation for his pizza? There were 8 parts which he divided his pizza into and he ate 4 parts out of the 8 parts. So we can say he had 4/8 of the pizza. So what half Rohan had? 2/4 of the pizza first friend had and 4/8 of the pizza second friend had. What do we see? What did we observe? We see that the same amount of pizza has been eaten. How? So we can say all of them had half of the pizza. How can we say that? Can you observe the picture? The pizza has been placed in this order. Okay, the way they have eaten or they have divided the pizza. See, Rohan ate half of the pizza. Yes, he divided his pizza in 2 parts and he ate half. First friend divided his pizza in 4 quarters and he had two parts. That means he ate same portion as was eaten by Rohan. And then his second friend divided his pizza into 8 parts and he ate 4 parts out of the 8 parts. 4/8 of the pizza he ate. That means he also had half of the pizza only. So all these fractions, half, 2/4, 4/8, what does this show? What do they show? They show and they tell you that they all had half of the pizza. Therefore, 1/2 is equal to 2/4 is equal to 4/8. They all represent the same amount, that is half of the pizza. They are all equivalent fraction. What are equivalent fractions then? What are equivalent fractions? Equivalent fractions are fractions that have the same value or represent the same part of an object. Here, the value remains the same, but the form of fraction changes. That means the numerator and the denominator will only change. Now you see the figures over here. Yeah, the size of the figure is same. Yes, only the fractional part in which or into which the division is done is different, whereas the shaded portion is different. So what do we see over here? What do you see? That the shaded portion of the two figures is different. So here 1 out of the 4 equal parts is shaded. So we have written 1 upon 4 is shaded. Whereas here we see 2 upon 8 is shaded. But the value is same. Yes, the region covered by, or the area covered by one shaded portion is equal to the region covered by 2 out of 8 parts. Both are equal. So can we not say 1 upon 4 is equivalent to 2 upon 8, or fraction 1 by 4 is equal to fraction 2 by 8? Yes, equivalent fractions are equal to one another. And how they are equal? They have the same value, or they represent the same part of the object. Are we good till here? Let's do one exercise on equivalent fraction. This is a worksheet, and the direction given here is color equivalent fraction as shown. First one is solved. Okay, the first one is an example which is already solved for you. It says 3 upon 4. 3 is the numerator, 4 is the denominator. 3 upon 4 is equal to 6 upon 8. How? That is shown with the help of a figure. 3 out of 4 is shaded. So 3 parts are shaded over here. Here 6 parts out of 8 to be shaded. So here 1, 2, 3, 4, 5, 6 parts are shaded. Now you will see that both of them, yes, both the figures are representing the same amount of area covered, and what is left out, yes, is the same area. So they are equivalent fraction. Let's do the exercise, then you will understand better. The first question says 2 upon 8. That means 2 parts out of 8 equal parts need to be shaded over here. And here 4 parts out of 16 parts need to be shaded. So the question is 2 upon 8 is equivalent to 4 upon 16. How do we read 2 eighth? 2 eighths. And this one we read as 4 sixteenths. And now let's solve this by shading. Okay. 2 parts need to be shaded. And in the next figure, how many are to be shaded? 4 out of 16 parts. 1, 2, 3 and 4. Okay, now what do you observe? Yes, in both the figures, here 2 are shaded out of 8 parts, and here 1, 2, 3 and 4. 4 parts are shaded out of 16 parts, but they both are covering the same area, right? Same amount of area is been covered by both the figures, so they are representing equivalent fractions. So fraction 2 by 8 is equal to 4 by 16. Same way you can do the remaining fractions. Same way you can do the remaining. Let me solve one more for you. It says 1 upon 2 and here it says 2 upon 4. Let's shade 1 out of the 2 parts and here let's shade 2 out of the 4 parts. And in the second, 2 out of 4 parts. 1, okay, now what do you see? That both of them have covered the same equal area of the circle. Here also half of the circle is shaded and here also half of the circle is shaded. Let's learn how to find equivalent fractions. Everywhere you will be not coloring, shading or giving pictorial representation, right? You will have to solve the problems also using numbers. So how do we solve and find out whether the given fractions are equivalent or not? To find equivalent fractions, we multiply or divide the numerator and denominator of the fraction by the same number except 0 and 1. What does this mean? This means that if you have to find equivalent fraction, you will have to multiply or divide the numerator and denominator of the fraction by the same number. That means if you are multiplying the numerator by 2, then or dividing the numerator by 2, then you will have to multiply or divide the denominator also by 2 only, not by any other different number. Now except 0 and 1, because 0 multiplied by any number, if you will multiply 0 with any number, the answer will be, the product is going to be 0 only. And 1 multiplied by any number, the product is the number itself. So except 0 and 1, any other number you use to multiply or divide to find the numerator, you multiply the numerator and denominator of a fraction to find the equivalent fraction. Now let's consider the previous example of pizza where Rohan invited his friends for pizza party and the mother made 3 pizzas, and where Rohan had half of the pizza, where the first friend had 2 parts out of 4 parts and the second friend had 4 parts out of 8 parts, and then we found that they all were equivalent fractions. If we multiply the numerator and denominator of 1 by 2, that is Rohan's part, by 2, then what do we get? 1 by 2 into 1 by 2, 1 is the numerator, 2 is the denominator. So we are going to multiply the numerator and the denominator by the same number, that is by 2 only. So we get 2 by 4, which is the fraction or the part or the amount of pizza eaten by the first friend. Yes. And if we multiply 2 upon 4, which is the fractional representation for the pizza eaten by the first friend, by 2, again, that is 2 into 2 and 4 into 2. Numerator and denominator by the same number. We are multiplying the numerator and denominator by the same number. And so what fraction are we getting? 4 by 8, which is the part eaten by the second friend. Yes, so we can say 1 by 2 multiplied by 2. Numerator and denominator gives you the fraction 2 by 4 for the pizza eaten by the first friend, into 2 again. Numerator and denominator gives you fraction 4 by 8. They all are equivalent fraction. They all are equivalent fraction because they all are giving you the same value. They all are multiplied by 2 only. So 1 by 2, 2 by 4 and 4 by 8 are equivalent fraction. Let's solve one exercise. Complete the equivalent fraction. Now we learned that equivalent fraction, to find equivalent fraction, we need to multiply or divide the numerator or denominator by the same number except 0 and 1. Now here the denominators are given but the numerators are missing. So to find the missing numerators, yes, and to make them equivalent at the same time, we have to find out that how many times of 5 the denominator 10 for the second fraction has come. So 5, 1 is 5. 5 twos are 10. So if your denominator is multiplied, if the denominator of your first fraction here is multiplied by 2, then your numerator should also be multiplied by 2. Yes, this should also be multiplied by 2, right? So what your answer will be? 4. What your answer will be? 4. Now next fraction we see that 15 is the denominator given. So now we will find out that how many times of 5. We will always take the first fraction, okay? We will not take the second one because in the second table 15 doesn't come, okay? So here 5 twos are 10, then here 5 threes are 15. 5 threes are 15. So we are going to multiply 5 3 times. Here 5 is multiplied 3 times to get 15. So if denominator is multiplied 3 times to get 15, then your numerator will also be multiplied by 3. Your numerator will also be multiplied by 3. So here we are going to multiply this by 3 and write down 2 threes are 6. Okay, so here we understand how to solve or complete the equivalent fraction. We need to multiply the numerator and denominator by the same number. If the denominator is missing, then we will find out how many times the numerator is, how many times numerator comes in the table, and we will multiply by the same number to find the denominator. And here in this case, since the numerator is missing, so we will multiply the denominator by the number to find how many times does 10 come in the table of 5. So 10 comes 2 times in the table of 5. 5 twos are 10. So we have multiplied the numerator also by 2 to get 4. Here 5 threes are 15. So we multiplied the numerator also by 3. 2 threes are 6. Same way we are going to complete the remaining ones. Let me do one more for you to understand. Here again we are seeing that the numerators are missing and denominators are given. That means 5 table we are going to read to find out how many times of 5 15 comes in, and in the table of 5 how many times does 25 comes. So we see that 15 comes 3 times, okay, of 5. 5 threes are 15. 5 threes are 15. So if denominator 5 is multiplied by 3, then your numerator will also be multiplied by the same number, by 3 only, not by any other number like say 4, 5, 6, 7 of your choice. No, if the denominator is multiplied by 3, numerator will also be multiplied by 3. And how this 3 number has come? Yes, this 3 has come by our choice? No, we have seen that how many, we have read the table of 5 to find out how many times of 5 15 comes. So 15 comes 3 times of table 5. So we will read the table of 3 3 times. 3 threes are 3 threes are 9. 3 threes are 9. Now we will see how many times of 15 does 25 come. Sorry, how many times of 5 does 25 comes? We'll read the table of 5 to find out 25. Read the table of 5 to find out 25. 5 ones is 5. 5 twos are 10. 5 threes are 15. 5 fours are 20. 5 fives are 25. So 5 fives are 25. 5 fives are 25. So this means that this denominator comes 5 times of table 5. So if the denominator is multiplied 5 times, that means your numerator 3 will also be multiplied by 5 only to get the numerator. So we will multiply 3 5 times. 3 fives are 15. So you get the answer 15 as your numerator. Now 3 by 5, 9 by 15 and 15 by 25 are equivalent fraction. They are equal to each other. Same way we are doing the remaining questions also. We are going to read the table of 9 to find how many times of 9 18 comes. How many times of 9? 2 times, right? How many times of 9 45 comes? 5 times. So we are going to multiply the numerator also by the same number. 5 twos are 10. Then here 5 is multiplied by 5. Here because the denominator 9 is multiplied by 5 to get 45. So we are going to multiply the numerator also by 5 to get the numerator. 5 fives are 25. Same way the last one, 1 by 6, 1 upon 6, 1/6 or a sixth is equal to is equal to numerator is blank by 24. So let's find out how many times of 6 24 comes. How many times? 6 fours are, yes, 6 fours are 24. And how many times of 6 30 comes? 5 times. 6 fives are 30. So we will multiply the numerators also by the same number. So here 1 4 is 4 and 1 5 is 5. So this is how you will solve your equivalent fraction exercise. Let's solve one more exercise to understand the concept of how we multiply or divide the numerator and denominator to find equivalent fraction. Here in the questions, instruction is complete the equivalent fraction. How will we complete the equivalent fraction? To complete the equivalent fractions, you will see that one side the numerator and denominator is given, but the other side the numerator is missing. You have to find this numerator, and to find this numerator you have to observe the question, understand it well, and then decide whether you are multiplying or dividing to find the next denominator. So here your denominator is 10 and here your denominator is 90. To reach from 10 to 90, from smaller number to greater number, you will multiply only, right? You will read the table of 10 to find 90. How many times of 10 is 90? Yes, 10 nines are 90. So if you are multiplying your denominator by 9, and the rule says that to find equivalent fraction, if you are multiplying your denominator by 9, then you need to multiply your numerator also by 9. So we will multiply the numerator also by 9. And so the missing numerator here will be 5 nines are 45. 5 nines are 45. So we get the fraction 45 as equivalent to 5 upon 10. Both the numerator and denominator are multiplied by the same number. And how have we got 9? By reading the table of 10, the number of times to reach 90. 10 nines are 90. And when we found 9, we understood that if the denominator is multiplied by 9, numerator will also be multiplied by the same number. So equivalent fractions are found like this only. We multiply or divide the numerator and denominator by the same number. Let's solve one more to understand this better. Here fractions are 2 upon 4 is equivalent to dash upon 20. We don't know what the numerator is, but we know the denominator. So the denominators which are there, 4 and 20, we have to find out that whether 4 is multiplied the number of times to reach 20 or 4 is divided by some number to reach 20. Obviously 4 is not divided because this number is bigger, and to reach a bigger number we will multiply only. So how many times of 4 is 20? 4 5s are 20. If denominator is multiplied by 5, that means we have to not think of any other thing. We have to understand that here only multiplication, that means upper number will also be multiplied. Same basic operation, multiplication means multiplication. Upper number will also be multiplied only. We will not multiply the lower number and we will divide the upper number. No, same basic operation, same number. So here if we are multiplying by 5, so we will multiply the numerator also by 5, and so we will get our missing numerator as 2 5s are 10. Okay, are we good till here? Okay, here question number 1 and 2 both were similar, but what do we observe? Question number 3 is also same. I'm not going to solve question number 3, that I'm going to leave for you. But question number 4 is different. How? Here we are seeing that the numerator of the first fraction is missing. Here the numerator of the second fraction was missing. Here the numerator of the first fraction is missing. How shall we solve this? Let's always first observe the question, understand, and then solve. First observe the question. Here numerator of the first fraction is missing. Both are to be written in equivalent form. The first denominator is bigger than the second denominator. So when the first denominator is bigger than the second denominator, in this case we are going to divide. We are going to divide. We are going to find out how many times of what table, how many times of what table is been read over here that 15 has come. So we can go opposite. 3, we can read the table of 3 to find 15. 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, 3 fives are 15. That means this 15 is divided by 5. This 15 is divided by 5. 5 threes are 15, or we can say 15 divided by 5 is 3. So if your denominator is divided by 5, the same concept is going to be used for division also. To find your numerator here, that if your denominator is divided by 5, numerator will also be divided by 5 only. So if I said that you read the table of 3 to find out 15, yes, so you read 3 fives are 15, so read 8 also. 8 fives are only. So how many times? 8 fives are 40. So 40 divided by 5 is 8, or we can say 5 eights are 40, or 40 divided by 5 is 8. So this is how we solve the missing numerator or denominator to make them equivalent fraction. And same question number 5 also. 9 by 2, 2, how many times of 2 is 40? 20 times. So if denominator is multiplied 20 times, numerator will also be multiplied 20 times, and so your numerator will become 180. So this two questions are left. You can solve and find out the answer, and I'm sure by now you must have understood how to solve equivalent fractions. So students, if you have found the session to be interesting, helpful, then please do like, share and subscribe to my channel. And for more videos like this, keep yourself updated, and until then, keep learning, keep growing. Thank you.